substitute for the sin x. But one more term is there which is with cos raised to 8x. Okay, so are you able to convert this into sine? Yes, because this is the 8th power. So what way I will write? I will write cos square because I know the formula in terms of cos square which converts sine raised to 4. So immediately I will write here formula and I am able to substitute. This way if we will start thinking, we will start with our example. Okay, so let I equal to integral cos raised to 8x cot x dx. We are splitted cot x as cos x upon sin x. Now next is what? You need to substitute sin x equal to t. So here is sin x equal to t. So what will be the derivative? Derivative is nothing but cos x dx equal to dt. So once if you know what is cos x dx equal to dt and you want sine, that means we need to split our cos raised to 8x. So cos square x raised to 4. Now we'll substitute for the cos square. Cos square is 1 minus sin square x raised to 4. Cos x upon sin x. So now it's easy to substitute. So we'll substitute immediately. 1 minus t square raised to 4. Cos x dx equal to dt. And we know that this is sin x is t. So you will get 1 minus t square raised to 4 dt upon t. You know how to find the expansion. This expansion is given by binomial theorem. What is your binomial theorem? That we'll use here so that you will get an expansion of 1 minus t square raised to 4. Okay, integral 1 minus 4t square plus 6t raised to 4 minus 46 plus t raised to 8 upon t dt. Now this is by using binomial theorem. So we'll discuss the binomial theorem. Now you are having a minus b raised to n. Actually you are using this, but binomial theorem is related to a plus b raised to n. A minus b raised to n is nothing but nc0 a raised to n b raised to 0. Alternate you will get plus minus sign. So nc1 a raised to n minus 1 b raised to 1 and so on. The rth term will be minus 1 raised to r ncr and a raised to n minus r b raised to r, because this power must be equal to n. Look at here, n minus 1 plus 1, n plus 0, which gives you again n. So every time the power of both the unknowns is sum of the powers is equal to whatever the power is given to you. So that is called as expansion. Also one more thing you are studied, that is 1 minus x raised to n. What is 1 minus x raised to n? That is 1. Alternate now nx plus n into n minus 1 upon 2 factorial x square and so on. Okay, alternate you will get plus minus sign. So same thing we are going to use here. So by that formula, what you got? You got this value as n. What is n here? N you are having 4 and what is your x? X is t. So what is the expansion? 1 alternate plus minus sign n into x. So what is the x here? X value is t. So you will get t square. Then you are having plus sign n into n minus 1 upon. So 4 into 4 minus 1 is 3. That means 4 into 2 divided by 2. So you will get 2 3s are 6. So you are getting 6 and t square its square. Okay. Now next is what? Because fourth power, till fourth power you are having 5 terms. So first term, second term, third term, then you will have with negative sign fourth term and fifth term. Now also you know that how to find this coefficient. That coefficients are given by 1 to 1, 1, 3, 3, 1 and you will get 1, 4, 6, 4, 1. Look at here. What is the coefficient? 1, 4, 6, 4, 1. Here it is 1. So this is also a triangle which you are already studied in 11th standard. So you are able to find the coefficient by this method or expansion. Any method you are able to use. But when you are able to combine, only if you know the previous knowledge. So you got this expansion. Okay. So 1 minus 4t square plus 6t raised to 4 minus 4t raised to 6 plus t raised to 8 upon t. Now separate the denominator. Separation says that it is 1 upon t. Then minus this separation gives you 1 upon t minus 4t square upon t plus 6t raised to 4 upon t minus 4t raised to 6 upon t plus t raised to 8 upon t dt. Now look at here. So, one power will be reduced 1 upon t as it is here. Then here 1t will get cancelled, so you are getting 4t. Here 1t will get cancelled, so what you will get? T cube, so you will get 6t cube. Then here you will get t raised to 5 and here you will get t raised to 7 dt. Now this is simple function, separate the integration, so you will get this as, this is nothing but separation of integration of 1 upon t dt. Then you are having minus 4 integration of t dt. Then you are having 6 into integration of t cube dt. Then you will have minus 4 into integration of t raised to 5 dt. And the last one is plus integration of t raised to 7 dt. Plus constant of integration. So here you will get log t. Here it is log of mod of t. Here you are having t. So you will get t square upon 2. Then here you are having t cube. Third term will be t cube. So you will get t4 upon 4. Fourth term will be t raised to 5. So you will get t raised to 6 upon 6. And this is t raised to 7. So you will get t raised to 8 upon 8 plus constant of integration. And simplification as usual. 2. Now here you will get 2 and 3. So 2 3s are 2 2s are and 8 as it is. So what you will get? Final answer, that is log of mod of sin x, because you are replacing your t sin x, minus 2 value of t square, that is sin square x, 3 by 2 value of t raised to 4, that is sin raised to 4. Here you are having 2 upon 3, so you will get 2 upon 3, sin raised to 6x, 1 upon 8, sin raised to 8x plus constant of integration. This is your final answer. Okay, so from this you will get immediately your final answer. And now next example. Your next example is integration of tan raised to 5x dx. Okay, now here there is only tan and you are having the odd power of it. It is given for that only, because you are able to split that fifth power as cube plus 2. Okay, now 2 means tan square, and for tan square you are having an identity as sec square x minus 1. So immediately if you will substitute for the tan, you will get the derivative sec square x plus c. This is all about the substitution method, whatever we are doing. So we will start with that. Look at here. This is your integration tan raised to 5x dx. Now what will be the next? Next is whatever I have discussed here. What it is? You have to split the power. That is tan cube x tan square x dx. Now this tan square x dx you are able to write as sec square x minus 1. So tan cube x as it is, sec square x minus 1 dx. Now separate the term. This separation gives you tan cube x sec square x in one term and tan cube x into 1, that is tan cube x dx. Again you replace here tan x into tan square x, because by tan cube x you will not get any integration or there is no formula. So we need to split it. And that's why we are splitting for substitution. So we'll begin with that. So as it is, I will write this example here itself. So you will get this term as it is, tan cube x sec square x dx. But here is the splitting. Tan cube x is tan x into tan square x dx. As usual, you need to substitute the value for tan square x. So what will be the next step? Next step will be this term as it is. Then you are having tan x and this value is sec square x minus 1. Again you need to multiply. So by multiplication what you will get? By multiplication you will get tan cube x sec square x dx. Then you are having minus sign tan x sec square x dx. This minus and this minus becomes plus and integral tan x dx. Okay. Now this is totally simplified function, because if you substitute for tan x, you know that sec square x dx is dt. So this you will get as t cube. Similarly here, if you substitute for tan x, you will get this as sec square x dx as dt. and this is nothing but directly formula, that is integration of tan x dx. Okay, so that formula we are going to use here directly. You know the formula. Have you by hearted? I think you have written the direct formula. Okay, so we'll write here tan x equal to t, therefore sec square x dx equal to dt. Do you remember the formula for the integration of tan x? So that is nothing but log of mod of sec x plus constant of integration. We have seen its working also. So you must know that formula every time you write that formula, so that it will be easy for you to remember, because writing is the greatest practice of remembering. So you will get this as log of mod of sec x plus constant of integration. Write that formula, whichever formula you are using, that again and again. So here it is integration of tan raised to 5x dx equal to integration of t cube dt minus integration of t dt plus log of mod of sec x plus constant of integration. Now this is nothing but you are using the formula x raised to n dx. What is the formula for x raised to n dx? X raised to n plus 1 upon n plus 1 plus constant of integration. So you will get t raised to 4 upon 4, t square upon 2 plus log of sec x. Okay, so here it is t raised to 4 upon 4 minus t square upon 2 plus log of mod of sec x plus constant of integration. Okay, now look at here. So again replace the value, that is tan raised to 4x upon 4 minus tan square x upon 2 plus log of mod of sec x plus constant of integration. Okay, so this way this example is completed here. We'll see the next example. Look at here, the example is, this is now bigger example. Tan 3x into tan 2x into tan x dx. Now there will be a problem because you are having 3 functions at a time. Okay, but thing is that observe this function properly. You are having product of 3 tan functions. Okay, then one more thing you have to observe, that the angle, is there any relation between these angles? Yes, because sum of these 2 angles, I am talking about angles, so sum of 2x plus x is 3x. So are you able to split an angle in such a way that you will get these 2 angles, and that is only the expansion of tan 3 theta. What is the expansion of tan 3 theta? Now we'll see tan 3 theta equal to. So we'll start with this formula. This you are already learned in 11th standard. Also here we are learned in the trigonometric functions also. So we'll begin with that. We know that tan of 3x you are able to split as 2x plus x. As usual, you know that this is tan a plus b. Tan a plus b is what? That formula also you have. That is nothing but tan a plus tan b upon 1 minus tan a tan b. That we'll use here. So what you will get here? You will get here as tan 3x is equal to tan 2x plus tan x upon 1 minus tan 2x into tan x. Now look at here. If you will cross multiply, that means take this denominator to other side. Once if you will take the denominator to other side, you will get the product. What is the product here? Product is tan of 3x into complete denominator. That is 1 minus tan 2x into tan x equal to tan 2x plus tan x. Now here you need to multiply. So multiply by tan 3x. If you will multiply by tan 3x, you will get this value as tan 3x minus tan 3x tan 2x tan x equal to tan of 2x plus tan x. We want this value. Okay, we want this replacement. Look at here. That is tan 3x tan 2x tan of x. It's a product. We are converted that into addition and subtraction. So for that we will take this side and 2x plus tan x this side. So what you will get? You will get this your function as what it is. That is tan 3x tan 2x tan x equal to tan 3x minus tan 2x minus tan x. Now this is separated function and it's easy to integrate. So we'll start with that. Look at here. integral tan 3x, tan 2x, tan x dx is equal to, that is nothing but it is sum and the difference of the integrals, that is tan 3x minus tan 2x minus tan x dx. Now separate out the term. If you will separate out the term, you will get integral of tan 3x dx minus integral of tan 2x dx minus integral of tan x dx. Now we are using the formula tan of x dx, and just now I told you it is log of mod of sec x plus constant of integration, that we are using. But here you are having 3 is multiple of it, 2 is multiple of it, so you will get that in the denominator by using the property f of ax plus b dx is equal to, you know that if it is a capital F of ax plus b, so you will get f of ax plus b upon a plus constant of integration. This corollary also we have already seen. So according to that, we will get the values of this example. So what is the value? Look at here. 1/3. 1/3 means upon 3. Log of mod of sec x 3x minus half log of mod of sec of 2x minus log sec x plus constant of integration. This way we are completed with this complete. That means if there is a product, you know that it may be splitted as 2 theta plus theta. Any angle, and that way only the functions are given. That if you are going to, and this is only about the tan and cot. Only in tan and cot this type of examples are there. In your text only one example is given, but you are able to write this for any angle. 5x also if it is there, you are able to split that example, and you are able to write as 3x plus 2x. Accordingly, whatever angle you are having here, either you are able to write 4x plus x and then expand. And by expansion, whatever may be the product, you are able to convert that into sum or the differences of the functions. And this kind of examples they may ask in JEE. So next example. What is next example? Integration of 3 raised to cos square x sin 2x dx. Where is the problem? You have to start thinking in that manner. Where is the problem? Problem is here. That is the power of the constant term is a trigonometric function, and apart from that it is a square of it. So we'll start thinking that we don't want this, means we want to replace this. To replace means substitute. And as usual, you will get a raised to some simple function a raised to x. So you are able to solve that. So we'll begin with that. So what is our beginning? Beginning will be substitute cos square x equal to t. Look at here. Cos square x equal to t. That means now differentiate. By differentiating, what you will get? Differentiating, you will get 2 cos x. That means power first you will differentiate. So 2 cos x, and then derivative of cos x is minus sin x dx. So this side you will get dt, no problem. Now here you will get minus 2 sin x cos x dx equal to dt. You know that what is 2 sin theta cos theta? 2 sin theta cos theta is equal to sin of 2 theta. We don't want this negative sign. So we'll keep that negative sign as it is. So what you will write? You will write minus sin 2x dx equal to dt. And negative sign you take other side. So because you are having only sin 2x dx equal to minus dt. That will substitute in our given integration. So what will be your integration? Your integration becomes 3 raised to t minus dt. So 3 raised to t minus dt, minus sign you are able to take common. That means out of integral sign, you will get 3 raised to t dt. Now this you are using the formula integration of a raised to x dx. So what is integration of a raised to x dx? Integration of a raised to x dx is a raised to x upon log a. Okay, plus constant of integration. So you are able to solve this. So immediately replace the values a and x, you will get your variables. So we'll start with our example. Look at here. So it gives you 3 cos square x sin 2x dx is 3 raised to t minus dt. That is minus integral 3 raised to t dt. Now what will happen? That is 3 raised to t minus upon log 3 plus constant of integration. And now replace the value, because that is cos square. So you will get this as minus 3 cos square x upon log 3 plus constant of integration. Okay. So now this is all about the 15th example. Now next example is sin x into cos cube x upon 1 plus cos square x dx. Now look at here. This example is in numerator you are having cos square x and in the denominator 1 plus cos square. There is no 1 minus cos square. So we'll start whatever the procedure is given previously that you need to substitute. So substitute cos x equal to t. Because we don't want this sign. We'll keep all functions in terms of cos. So minus sin x dx equal to dt means sin x dx equal to minus dt. Now you left with only cos. So what you will get? You will get here as sin x cos cube x upon 1 plus cos square x dx as this minus sign is there because it is minus dt and you are having t cube upon t square plus 1. Now t cube upon t square plus 1 means one factor you must have t square plus 1 for the numerator. That means if you take t common, so t cube becomes t. So you are having t cube plus t which you don't want. So you have to write minus t. So for that this substitution is there. T cube plus t minus t. Look at here. This is from only the observation that is in the denominator you are having t square plus 1. If you want t square plus 1 here, that means t cube is there. You split this as t into t square. Now again you want plus means plus t, then only you will get t square plus t, but t plus t is extra, you have to write minus t. Okay. So this way you will start thinking, then only you will get this substitution. Look at here, minus integral t cube plus t minus t upon t square plus 1 dt. Separate the term. Which term? These two terms together and this term will be separated out. Okay. Now look at here, minus sign is there. Inside the bracket, minus sign will carry throughout and then only will come to conclusion. Look at here, t into t square plus 1 for this upon t square plus 1 which I have already explained, minus t upon t square plus 1 which is equal to minus. Now this minus is here and minus of minus, this minus and this minus becomes plus here. So you will get here t square plus 1 will get cancelled. So integration of t dt. And now look at here. Now what will be the derivative of t square plus 1? Derivative of t square plus 1 is 2t. But you are having only t. So you multiply and divide by t. So you will get half 2t. So here is half 2t upon t square plus 1. Okay, these are the substitutions. So these are the adjustment you can say. Now what is the integration of minus t? So you will get here integration of minus t dt is minus t square upon 2 plus half. So now look at here, plus half, this is f dash t upon fx. So you will get log of mod of t square plus 1 plus constant of integration. Now re-replace the values. By re-replacing the value, what you will get? This is minus cos square x because t value is cos. So you will get cos square x upon 2 half log of t value is cos. So cos square x plus 1 plus constant of integration. Okay. So this way we are completed with this example. We'll stop here. We'll continue in the next lecture. In this lecture, we are started with exercise 3.2a, which we are finished with the exercise 3.2a. We'll see the next lecture with some few more examples. Thank you.